In the first video, we started with a polynomial, and our goal was to figure out what the zeros were so that we could graph it. What we're going to do now is we're going to do things in the reverse order. We're going to start off with zeros being given to us, and we're going to figure out a polynomial that has those zeros. So let's find a polynomial of degree 4 that has zeros -2, 0, 1, and 4. We know that if a number is a 0, so we know that if 4 is a 0 of a polynomial, then x minus that number, in this case x minus 4, is going to be a factor. So what this means is here x minus 4 needs to be a factor. Here x minus 1 needs to be a factor. Here x minus 0, or just x, needs to be a factor. And here x minus -2, which is the same as x plus 2, needs to be a factor. And so one example of a polynomial that's a 4th degree, because we've got 4 factors, 4 linear factors, that has these as its zeros is going to be this. And if we go through and multiply all of this out, we can get it in a more standard form. X plus 2 times x is going to be x squared plus 2x. X plus 1 times x minus 4 is going to be x squared minus 5x plus 4. I am foiling and I'm combining like terms in my head. And then if we need to multiply these out, we can go ahead and use the table method. We've got x squared 2x, and then we've got x squared -5x and 4. When we multiply, this gives us x to the 4th, -5x cubed, 4x squared. We've got 2x cubed, -10x squared, and 8x. And when we combine the like terms, this gives us x to the 4th, and then minus 3x cubed minus 6x squared plus 8x. So we can go the opposite way. Instead of starting with a polynomial and looking for the individual zeros, we can start with the zeros and work our way in the other direction to get a polynomial. Now, what is another polynomial that has these same numbers as zeros? What can we do to a graph that doesn't change its zeros? Well, one of the things we can do is we can do a vertical stretch, because we know that when we stretch things, everything that started off on the x-axis, which are the zeros, ends up staying on the x-axis. So if we wanted to do a vertical stretch or a shrink, that would give us another polynomial with the same zeros. So we could stretch this vertically by a factor of 2. And if we did that, stretching by a factor of 2, that gives us 2x to the 4th minus 6x cubed minus 12x squared plus 16x. We could do a vertical stretch or shrink by any factor. We could also do a vertical reflection across the x-axis. That doesn't change where our zeros are. If we did that from our original function, we get -x to the 4th plus 3x squared, 3x cubed, plus 6x squared minus 8x. there are actually an infinite number of examples that work here because we can stretch and shrink by any non-zero quantity. And so all of these are examples of polynomials that have the zeros that we wanted. It's not too often that we'll actually have to do this, starting from the zeros and work our way to the polynomial. But the more we know about polynomials, the more tools we have, the more ways we can look at them, the more comfortable you're going to be with them and their graphs and their zeros, and the better off you're going to be moving forward.